Now, how far did we get? So we're ready for E. All right, so we are ready for problem E. Let's everybody pay attention and review these steps. We are going to sketch this. And in order to do that, we need to put in the asymptotes and the intercepts. Now, let's look at the problem. Who has a thought on how we could start? Savannah? Yeah. Let's factor the bottom. Oh my. Here comes Jamal.
Yes, you made that caption.
Okay. Now, who remembers anything from Friday about how I'm going to get asymptotes or intercepts in the picture, Mr. Brokaw? Whatever makes the denominator 0. That's exactly right. So I should hear no talking. You should all be listening intently because tomorrow we have a quiz over this.
Ford,
Yeah. Yes?
please send Savannah Louder back to Mrs. Witcher's office at your earliest convenience.
Okay.
Thank you.
I'd rather you stay. Do you think it's an emergency? If you need to go, go ahead, but come right back, okay? Vertical asymptotes. When the denominator equals 0. So there's going to be 2. X equals 3 or x equals -1. So x equals 3 is right here. X equals -1 is right here. Now, I don't want anybody asking me in the future, how do I find vertical asymptotes? I just told you. Where do vertical asymptotes come from? Whatever makes the denominator 0. Good. All right. Anything that we need horizontal asymptote and we need our intercepts still. Anybody remember any of that? What kind of outfit is that? Julian. I know it's a great sweatshirt, but it's not a legal sweatshirt.
You can see right now for it.
Who remembers something? What? So Lauren says, let's look at our original problem. Let's take a look right here. Uh-oh, we have a problem. There's x squared on the bottom, but there isn't an x squared on the top. What happens when the bottom power is bigger? 0. So we have a horizontal asymptote at 0. There are 3 things. What do you do, Brokaw? There are 3 things that can happen when you look at those fractions. Let's look at these. Okay, wonderful. When you look at your fraction, you can have an x squared over an x squared. In that case, if that, let's say we had 4x squared over 3x squared, that horizontal asymptote would be at 4/3. Or you could have what we have, which is an x over an x squared, and that horizontal asymptote would be at 0. because the bottom is bigger than the top. Or you could have the other way around, you could have x squared over x, in which case there is no horizontal asymptote. Okay, so nobody's going to ask me again, how do we find the horizontal asymptote? We just went through it. To find the horizontal asymptote, you look right here. If they match up, x squared, x cubed, whatever, then the fraction is your asymptote. If they don't match up, if the big power's in the bottom, it's 0. If the big power's on the top, there simply isn't a horizontal asymptote. Okay. Anybody remember anything about the intercepts? We need those yet still in our picture. John?
For x-intercept, or no. Yeah, x-intercept you said it'd be 0.
Exactly. Your intercepts are these points right here. Those are the intercepts. So if I want to know what the x-intercept is, I'm going to let y be 0, which is exactly what John just said. Let y be 0. So that would look like this. 0 equals x plus 5 over x minus 3, x plus 1. Now, when I solve that equation, I'm not frightened of it. When I solve it, I'm going to multiply this over to here. But that's a 0. So what happens? I don't care what this is. When you multiply it over here, what are you going to be left with? 0. So what's your x-intercept? -5. Now, some of you might be thinking, wait a minute, Mrs. Ford, you told me that was an asymptote. You can actually have points on your horizontal asymptote. Now, we don't always, but we do sometimes. You will never have a point on your vertical asymptote. That's not possible. But you can have a point out here, that's okay. All right, so that's my x-intercept. Nobody's going to ask me again, how do I find an x-intercept? To find an x-intercept, you let y be 0 and solve your equation. Okay, now what about the y-intercept? Put 0 in for x. So if I did that, I'd have 5 on the top, and on the bottom I'll have -3 times 1 if I put in zeros for all of my x's. So I have a y-intercept at -5/3. You guys, that's not much to go on. I'm not sure what this looks like. But I do want you to think about something. This is the only place that you can cross the y-axis. And this is the only place that you can cross the x-axis. So with that in mind, do you have any idea what might be happening in the middle part of this picture between these two asymptotes? Do you have any idea what that might look like, Trey?
Maybe a parabola?
Yeah. It has to be something like this, you guys. I don't know the exact shape, and you don't need to worry about the exact shape, but it has to be something like that. Jamal?
It could be like cubic and stuff.
Okay. It could be, but not in this problem, because if it were a cubic, it would have a shape like this, right? And what does it do right there? And what did we just say? That's the only place it can cross. That's the only place I can cross the axis. So, Jamal, you're exactly right. I basically have two choices. I either have a parabola in here, or I have one of those. It can't be that because it doesn't cross the axis. So therefore, it has to be the parabola. Now, over here, I think I have two choices too. My two choices would be that shape or that shape. I have no idea which it is, but I can tell real easily if I plug in 1 point. Because if I put in, let's see, what would that be, 4? If I put in 4, it's either going to be a positive answer or it's going to be a negative answer. Remember, I can't cross the axis. So if 4 gives me a positive answer, then everything's got to be positive. If 4 gives me a negative answer, then everything's got to be negative, because I can't cross. So everything's either up here or down here. So let's put 4 in and see what happens. What do I get when I put 4 into my top? I get 9. And if I put 4 into the bottom, I get 1 times 5. Now, I don't even care about the actual number. Is that positive or negative? Positive. So this is the shape that we have. Now over here, I know if I've got a point, I have 2 choices again. That's it, 2 choices. It either comes down like this, or it comes up like this. So what could I do to figure out which one it is? It has to be one or the other. What do you think? Maybe put in 1 point, and it's either going to be positive or negative, just like before. So the point I put in might be -2. So let's put -2 in, and when I put -2 in, I get 3 on the top. Now I'm putting -2 in. So that gives me -5 times -1. Now again, it's not even the actual number you care about. Will that result be positive or negative? Positive. So we're coming in from the top again. And there's your picture. That was E. Now we're going to add a wrinkle. Let's go to F. Now I know this is a lot and it can be confusing, but you've got to learn each piece. So let's see if we can start putting these pieces together. Step 1. What do you think? How should we start? Factor it. How does the top factor? How about the bottom? Does it factor? X plus 1, x minus 1, difference of squares? Now, something very special happened.
There's 2 of the same.
These 2 will cancel out. So there's a hole. We're going to have a hole in this picture. Because we had a cancellation, it's called a removable discontinuity. We'll call it a hole. We have a hole in our picture. Where will that hole be? Kids, it is a point. We're going to plot it on our picture. Where will it be? What is the x-coordinate of the hole? -1. Why is the x-coordinate of the hole -1? Because that's the factor that canceled out. If x minus 2 had canceled out, where would the hole be? At 2. Now, we canceled it out. This is our new equation. This is where we're focusing all of our energy right now. if x is -1, I need to figure out what y is. So what am I gonna do with that -1? I'm gonna plug it in. So I get -1 minus 4 or over -1 minus 1. Now this time I do need to simplify that. I need to know what that actual number is because I'm gonna plot that point. So what is that? -5 over -2. 5 halves. So on my graph, at the point -1, 5 halves, I'm going to put a nice little open circle. A hole. How's come I haven't had any holes in any of my problems up to this point? Nothing canceled out. In order to have a hole, you have to have this. Moses?
How'd you get the -1 again?
That's the factor that canceled out. That's the x value of the factor that canceled out. Now, every bit of your focus now is right here. Not there, right here. Tell me about asymptotes and intercepts of this. This is where we're looking now. What do you know, Julian? The horizontal asymptote is at 1. Does everybody see that? You have x over x. If you did look at the beginning problem, it would still be the same. You have x squared over x squared. All right, Savannah.
X-intercepts at 4.
Okay, there's only one x-intercept. We're going to set this problem right here equal to 0. I bring this over, it says x minus 4 equals 0, so we have an x-intercept at 4. You're exactly right. Austin, what about a vertical asymptote? I have one. Where is it?
Just 1.
X equals 1. Because that's what makes the denominator 0. Now what am I missing? My y-intercept. Anybody remember how to find the y-intercept? Put 0 in for x. So if I put 0 in for x, I get -4 over -1, which is 4. Now, that's everything important. At this point, can you visualize it? Because if not, you're going to plot some more points like we did last time. Do you have enough to visualize it here? I think maybe you do. Can you see that? And what about over here? What's happening? The mirror image? That wasn't so bad, was it?
I mean, you know you have the sides, they always have to be going in opposite directions.
They don't have to be, but they almost always are. They do not have to be. All right, we have one more example to do. Are you ready for it? Everybody ready? Here's what I'd like to do since this is our last example. Let's talk about how we get started. And then let's see if everybody can get started and start finding some of the stuff on your own. Okay, big problem. Big, big problem. How do we get started? Factor. All right, so here we go. Now, some of you just totally freak out when you have to factor something like this. All you're doing is unfoiling it. So whatever is here, if I were going to take these two parentheses and FOIL them, when I multiply first times first, I have to get 2x squared. That has to be 2x and x. There is no other way to get 2x squared. 2x times x. Now I need to get 3. Actually, I need to get negative 3. So when I multiply last times last, I have to get negative 3. Again, I don't have a choice. That's negative 3 and positive 1. Or positive 3 and negative 1, right? That's the only way to get 3 when I FOIL. However, some of you have noticed, Mrs. Ford, when I actually do FOIL this, I get my 2x squared at the front, and I get my minus 3 at the back. But in the middle, I would have a 2x minus a 3x. That does not add up to 5. Okay, that must mean I put these two numbers in the wrong spot. Now, I still have my 2x squared and I still have my negative 3. But now I have a 6x minus a 1x. Well, shooty tooty, it still doesn't quite match because this adds up to positive 5, which means my signs are wrong. Now it works because I hit negative 5. What do I have on the bottom?
X minus 3x minus 1.
Minus 3 minus what? Oh, we're excited. What do we notice? We have a hole. And that hole is going to be at what? Where? 3 comma something. 3 comma something, because that's what canceled out. How do we find the something? Plug in 3, and where do I plug in 3? My new problem right here. That's history. I simplified it. I'm here now. So when I put in 3, what do I get on the top? 7. And what do I get on the bottom? 2. So I'm going to plot my hole at the point 3 comma 7 halves.
How'd you get the Y one again, Mrs. Ford?
Same way we did last time, Moses. We take the 3 and plug it into our equation. This is an x, Moses. How do you get y? Plug in x. Anytime we have x and y, we just plug it in. Now I'm going to make a list of what else I need you to find. I need you to find any vertical asymptotes, horizontal asymptotes, x-intercepts, and y-intercepts. And remember, these are points. X-intercept, y-intercept. Those are points. So take a minute and see if you can find any of these from this equation right here. This is the equation we're dealing with. See if you can put any of those into your graph. Don't say it out loud. Just try it on your paper. I'll wait a couple minutes and then I'll start putting stuff up there for you to check. Did anybody have any luck finding any of this? Anybody find a vertical asymptote? Where'd you put it, Harry?
1.
X equals 1. So we have a vertical asymptote at x equals 1. One more time, that's what makes the denominator 0. Zach, Mark, did you find a horizontal asymptote?
Yeah, it'd be a 2.
It's a 2. It definitely is a 2. You have 2x over 1x, or 2x squared over 1x squared. Your horizontal asymptote is at y equals 2. Jennifer, dear, did you find either one of these guys? Okay, is the x-intercept, what did you say? To find an x-intercept, we would solve this equation. We would let y be 0. When she multiplied this over here, it's still 0. So then she solved this equation and got negative 1/2. You are exactly right. Negative 1/2 comma 0. That's your x-intercept. Google. Did you get a y-intercept?
You just plug in 0 for the x, right?
And what happens when I do that?
Just 1 or 0.
Be careful, when you put 0 in here, what do you get on top?
1.
1. What do you get on the bottom?
Negative 1.
So your answer would be
0. Negative 1.
negative 1. Anybody have a question about any of that information that I got so far? Because the next step is now, I gotta figure out what the shape is. Are we good on all of that? Okay, now I need a shape. Can you visualize it? A couple of points right here, so it looks like when I connect those, maybe I get this. I kind of missed that one. What's happening over there? Same thing. Don't forget, it's got to go through the hole. So it looks like that.
Did you miss that on purpose, or is it?
No, I missed that still.
Oh, okay.
I should have missed it. I got a little bit carried away with my slope there. Got it? Okay, let's do a practice quiz. You can do it with your neighbor if you'd like. Get it ready for tomorrow. It's something that looks like this. Okay, let's go. Let's see if it's Jack, most right here.
Hold on, it's right on the equation.
Now, the things I will be looking for in your graph are these things. And then I'll look at the shape.
So, you see. 2 and 5 at the bottom.
See how much progress you can make. What should everybody be doing first? Factoring. Everybody should be factoring.
So, it like puts you off, but I don't need to. Would it be both? It would be, yeah, both. Over, okay, the top right back. X minus 2, X plus 1, right? Y. Oh, okay, it's a negative. So it's a negative 1. You can
Tomorrow will not be
so
through, so make sure you know what's going on here, folks.
Oh my God, wait. X minus 2. Are you struggling? Oh my gosh, wait, one whole.
Oh, are we doing this one?
Okay, so we have a whole. Yeah. Right. So then that's going to
To the x minus 2 is cancelled.
is going to be 2, comma. So then this is the equation. So then you're going to put a 2 in. So 2 plus 1 is 3. 2 minus 5 is negative 3. So that's negative 1. Okay, awesome. So I'm trying to
At this point, everybody should have found you have a hole. Because everybody should have factored. Okay. Where did you identify your hole, kids? Where x equals 2 and where y equals negative 1. So everybody should have a hole at 2, negative 1. Any question about that? Cole, you guys got a hole at 2, negative 1? Jennifer? You put 2 in.
I'm like Peter Pan on this.
So what's 2 plus 1? Because that's
is
what
when you look at this.
That's what canceled out.
And the horizontal is not just
It's like my
Now, where did you put your vertical asymptote? X equals positive 5. Kids, vertical asymptotes happen when the denominator equals 0. What will make that equal 0? 5. Where is your horizontal asymptote? Y equals 1. Now the intercepts. If you want the x-intercept, you have to let y be 0. When you do that, you multiply this over here and it just disappears. So x equals negative 1. Your y-intercept you're gonna let x be 0. So what happens if you put a 0 in for the x's? -1/5. Anybody have a question about this, the important stuff, the asymptotes, intercepts, holes? Because if you can get all that in place, you're almost home. Now you just need to create a picture. So can you visualize it? How's that look? Now you might stop there though, and I'm gonna have to take points off because you haven't finished your picture. There's this piece, but there's also this piece. And you might say to yourself, but Miss Ford, there's no points up there. Right now there aren't. If you need to plot some, go ahead and plot some. Now, I'm not going to give you some tricky, wacky problem tomorrow. It's going to be very much like this. So Jamal's question, are the branches of the curve always opposite each other? What was my answer to that?
Yes.
Almost always. I'm not going to give you some freaky thing where it's not.
So the vertical, no, that was kind of 5, and then
We have a few more problems tonight to practice. In addition, pay attention to this. In your note sheet, on the very back page of your note sheet, there is something called homework practice problems. The first 2 are part of your homework tonight. So it's on the back side of your note sheets, the very back page. Down at the bottom, there are 2 extra homework practice problems to help you gear up for the quiz tomorrow. We will go over 1 homework problem before we take the quiz. So do your homework. If you have a question, go over that before we take the quiz. Everybody got it? You actually could get started right now. You have 5 minutes. You maybe could get a problem done. And we could check it. Wouldn't that be a novel idea?